Hi friends, in this video we are going to see when R and L and C are connected in series. RLC series circuit. RLC series circuit. Now let us draw the circuit. R L C. RLC connected in series and excited by using AC source. RLC. So all these three elements are connected in series. Now where IR is the drop across the resistors, IXL is the drop across inductor, and IXC is the drop across a capacitor, and this is what E that I am using now. Similar to the earlier case or previous case, let us analyze this circuit by using a phasor diagram or phasor representation. A reference vector I am trying to take, that is, you understand it as OA, and I is the reference vector now. So before getting into the phasor, I would like to give one more analysis, that is, can I write E is equal to IR plus IXL plus IXC. So this is by applying the KVL to the loop or circuit. E is equal to IR plus IXL plus IXC. Nothing but IR is the drop across resistor, IXL is the drop across inductor, IXC is the drop across capacitor. If you sum all these three, then that will be equal to the total voltage whichever you are maintaining at the supply. Now come over here. OA is the reference vector. Now just I taken what? IA is the reference. Now what the first drop? First drop is what? IR. Now I am trying to write IR in phase with the I, because I said already I is always in phase with voltage for resistive load. Now let us go for the discussion of what? IXL. IXL is nothing but drop across inductor. Current is lagging voltage by 90 degrees, where if you try to discuss with respect to the drop, so IXL is going to be leads voltage by or else current by 90 degrees like this. So this is what IXL. I am just terminating it as B. Where the next drop will be available over here, that is capacitance IXC term, that is lagging. So this is IXC, where I am terminating it as or else C. Let's see. When this is phasor is represented in this fashion, now just I am trying to assuming three cases. First case, case 1. What is the case 1 is, just I am assuming reactance offering by the inductance is greater than reactance offering by the capacitance. This is what the case 1 I am assuming. I am assuming that inductance reactance is greater than capacitive reactance. So this is what the first case I am assuming, first case. So it means what I am trying to do is the same phasor OA, where it is I and this is IR, and this is what B, this is IXL term, and this is what IXC. The same I am trying to draw, but this is the case. In this case, what we are trying to analyzing? Just I am trying to assuming that the reactance offering by the inductance is higher than. So it means what I am trying to do is, so the same I am trying to representing by using the phasor. Now just I am trying to taking like this D. So why I am trying to take this means, just I assumed that XL inductive reactance is higher than capacitive reactance, so that the magnitude of this vector should be less than this, so that I am understanding. Just I am trying to extending this line like this, so BD. Now what the point just I am trying to assuming here is, this is higher, this magnitude is higher than this one, right? So it means what I am trying to do is, I am assuming BD is equal to AC. Here what it is showing, AC is nothing but capacitive reactance, BD is nothing but extension, whatever I extended, nothing but XL term is greater than XC. So it means I can understand in this also IXL term is greater than IXC term. So now I extended the line like this. I am assuming that this BD, the portion, extended portion is equal to this capacitive reactance. So this will be higher than it. So now similarly from this I can write AD is equal to AB plus BD. Yes or no? So this is what the total term, that what I can understand. So this is AD is equal to AB plus BD. So just I am trying to write like this. Now if I want to know this term, because I want to know this one only, right? So from this AB is equal to this total, AB is equal to this total AD minus, if I want to calculate this total, can I say, if I want to calculate this portion means AB is equal to AD total minus this portion, so BD. Yes or no? So now from this can I write AB is equal to AD, this BD portion or else this magnitude of the BD, nothing but this length of this vector is equal to AC that I assumed already. So instead of BD I can write AC. I can write AC. Now what is this? This is nothing but what? IR is the drop across resistor, IXL is the drop across inductance, but this is, I am assuming that XL term is higher than XC term. This is what the analysis. Now if I want to just I am trying to adding this. Now applying Pythagoras theorem, just I am trying to applying that for the circuit or else of phasor. Pythagoras theorem is equal to, or else OB square is equal to OA square plus AB square. This is from the right angle triangle OAB. OB square is nothing but what? Can I take E? Because this is nothing but summation of this. E square is equal to, what is OA square? OA square is nothing but IR square. What is AB square? AB square is nothing but ILXL square. Now E square is equal to I square. Sorry. Right. OA square, anyhow it is available. AB square is equal to, can I write AD minus AC? Yes. AD minus AC is nothing but this. AD is nothing but what? AB is nothing but AD. AD means IXL minus AC is nothing but, instead of BD I am trying to write AC. AC is nothing but IXC. So this is what? AB. Right. So OA is nothing but IR square. What is the AB term that I extracted is IXL minus IXC square. Now from this I square, R square plus XL square minus XC square. This is what equal to E square. So I square is equal to E square by R square plus XL square as XC square. You apply root both sides. I is equal to E by R square plus XL square minus XC square. Put a root over here. So this is what I. So it means, just I am assuming that this XL term is higher than XC term. This is what the analysis. I is equal to, I can get it as E by, I is equal to E upon under root R square plus XL square minus XC square. So here what the point to be understand here is XL term is dominating XC term. That's what the analysis I made. and this XL term will be higher than XC term. Now it means it is looking like, or else this will be behaving like what? Series RL circuit, because it is dominating the XC term, because XL is higher than XC means it is looking like, so the major part or else the highest part will be XL only. So now it is looking like I is equal to E by R plus XL square only. Why? Because it is dominating XC term. This was the case 1. Now let us take the case 2. What is the case 2 here is, case 2. What the case 2 is, XC is greater than XL, nothing but capacitive reactance is dominating XL, or else it is higher than XL. So indirectly IXC is greater than IXL. Now let us see the same phasor diagram I am trying to representing. OA, this is IR, right? Now here what the thing we have is, this is IXL, this is IXC, OA, B, C. Now in this case what I am trying to understanding, just this term, IXT term is higher than IXL. So just I am extending, this is D. So now from this portion, AB portion will be equal to CD portion, because if this portion is equal to this portion, then this term will be looking like higher than the XL term. Now from this, can I write it as AD is equal to AC plus CD. AD is equal to AC plus, instead of CD can I write AB? Right, because I am assuming this extension portion is equal to this one. So AB. Now if I want to calculate this AC, AC is equal to AD minus AB. So this is from the phasor. Now the summation of this. Summation of this is nothing but now OAC, triangle OAC is a right angle triangle. From this right angle triangle, again I am applying the Pythagoras theorem. So now I can write it as OC square is equal to OA square plus AC square. So now AC is nothing but what? This. AC is nothing but this one. If I want to calculate this one, AD is nothing but this is, AD is IXC, AB is IXL. OA anyhow it is IR square plus AC is nothing but what? IXC minus IXL whole square. And anyhow OC is equal to, I can write it as E square, because the sum will be equal to the total supply. I square is equal to R square XC square minus XL square. I square is equal to E square by R square XC minus XL square. I can be written as E upon under root R square plus XC minus XL square. So it is also very similar to the case of XC circuit, nothing but XC term here is dominating XL term. So now if you analyze this equation, it is looking like series RLC circuit. I is equal to E by Z. So this term, whole term will be called as Z only. So if you under root R square plus XC plus minus XL square will be treated as Z only. Z is nothing but an impedance. So I is equal to V by R. This term can be analyzed as resistance, but this is not a resistance. This is will be having a combination of inductive reactance or maybe capacitive reactance. In the case 1, XL or else inductive reactance is dominating capacitive reactance. In the case 2, capacitive reactance is dominating what it is? Inductive reactance. Now, let us go for the discussion of case 3. What the case 3 I am trying to do is case 3. Case 3. I am understanding or I am assuming XL term is equal to XT term. IXL is equal to IXC. So this is what the assumption in the name of case 3. Right. I am trying to write the same phasor OA. This is nothing but IXL term. This is nothing but IXC term. So this is B and this is C. In this case, what the assumption I made is IXL is nothing but IXC. So this term is equal to this term. Now let us see. This is OA, anyhow IR will be there. Right. In the case 1, I made it as XL term is greater than XC. In the case 2 term, case 2, assumed that capacitive reactance is greater than inductive reactance. In the case 3, I am assuming that both the reactances are offering by both inductor and capacitors are in same. Right. If these two are same, IXL term is and IXL term and IXC term both are same, and these two are in opposite direction. One is positive side and another is negative side. So if both the things having the same magnitude and in opposite direction means I can cancel out each other. The only vector that is remaining over is OA, that is nothing but IR, because these two terms cancels out each other, because I assumed that these two are equal in nature, or else these two magnitudes are equal. In this case, what the point to be analyzed there is, when both the reactances offering by inductor and capacitors are same, then those reactances are going to be cancels out each other. Finally, the leftover term is R. It means that if inductive term is dominating the capacitive reactance, then that circuit will be behaves like RL circuit. When reactance offering by the capacitance is dominating XL term, then that circuit will be behaves like RC circuit. When both the XL and XC both are same, then that circuit is going to be behaves like pure resistive network. It means that, so whenever practically if you try to observe, practically we cannot use resistive loads, or we cannot use inductive loads, or we cannot use capacitive loads separately. Load is nothing but it will be a combination of all kind of things. Nothing, motors are there, fans are we going to be uses, motors, fans, refrigerators, TVs, and lighting loads also. Because the loads are definitely the loads will be is the combination of RLC. So whenever the combination of RLC is there, when we need to analyze which of the component or which of the parameter is dominating, so as per that, the circuit is going to be behaves like that circuit only. If let us take an example, inductance is dominating capacitance, then that circuit is behaving like inductive circuit. If capacitance is dominating the inductive circuit, that will behave like capacitive network. So anyhow, whether you are taking resistor, whether you are taking inductance or capacitance, definitely that will be a combination of resistor, because you should understand definitely resistor will be there. Whenever you are using some kind of conductors means definitely it going to be offers finite amount of the resistance. So if inductance value is higher than capacitance, then that circuit is going to be behaves like inductive circuit. Whenever capacitance is dominating inductance, then that will behaves like capacitive network. Whenever the values of capacitance and inductance are same in nature, and then that circuit is going to be behaves like resistive network. So when that inductance reactance or else inductive reactance and capacitive reactance becomes equal is, so the condition of equaling those two is called as resonance. So it means that at resonance condition, resonance is nothing but it is a phenomena where the inductive reactance and the capacitive reactance becomes equal. So when those two values are becomes equal, then those two values are going to be cancels out each other. In that case, that circuit is going to be behaves like a resistive network. So that phenomenon where that reactances are becoming equal and cancels out each other, that phenomenon is called as resonance. Now I can say at resonance condition, the inductive reactance and capacitive reactance are going to be equals in nature and cancels out. That condition is known as a resonance. Or else at the resonance, that thing will happen. Now let us take an example. Whenever you are trying to applying capacitive loads, inductive loads and resistive loads at home, what the distribution companies, nothing but whoever sending the power to you, that fellows are going to be makes the compensation of both the reactances. If capacitive dominating the inductive, then inductors are going to be connected to compensate the capacitance. When inductors are dominating the capacitance, in that case, so capacitance or else capacitance is going to be used for the compensation of IXL term. So it means that always the distribution companies are tries to make the circuit as a resistive circuit. So if it is a resistive circuit, then the current or else the drop always in phase with the voltage, so that the current is also in phase with the voltage. So the angle between the voltage and current will be same. Then there is no phase difference will be there. If there is no phase difference, then the power factor will be good power factor will be there. For that reason why always we tries to compensate the inductive and capacitive reactances by putting a equivalent opposite reactances. When capacitance is dominating, inductor to be taken into the circuit to compensate it. When inductors are dominating, capacitors are to be taken into the circuit and to dominate the XL term. So this is what the analysis of IXL or RLC parameters. So at resonance condition, so where these two are cancels out each other, that particular thing is going to be happen whenever the circuit is undergoes with the resonance. Resonance is nothing but at the resonance these two reactants are going to be equals. In this way, the distribution companies are going to be, or whoever sending the power to you, those fellows are going to be compensate the reactances like this, and it means that circuit is going to be actually behaves like resistive network. Whenever it behaving like resistive network, then that circuit is going to be current always in phase with the voltage, angle between these two will be almost 0. So that reason why power factor will be improved. That I said already in the name classroom, that what is the power factor? It is the angle between voltage and current. So whenever angle between voltage and current is equal to 0, then power factor will be 1, cos 0, 1. So in that way the power factor will be improved. So RLC parameters is nothing but only the thing we need to understand here is when RLC is connected in series, if any one of the reactants is dominating, then that circuit will behave like that particular, nothing but if inductance value is dominating means that circuit is going to behave like inductive network. If capacitance is dominating means that circuit will behave like capacitive network. If inductance and capacitance both are in same magnitude, it means then those two are going to be cancelled out. In that case, that circuit is going to be behaves like resistive network. If it is behaving like resistive network, then the power factor will be improved. So this is the case with respect to the RLC circuit. Thank you.